We're going to go over the link calculator this morning. Hopefully you guys can get some benefit out of this. I know this is a very important piece when you're planning your link. So we have put this into play for all of our equipment as well as third-party equipment. What this allows you to do is create like a virtual link using Google Maps, so you can actually place all your equipment on the map, and it takes into account for your strength of your antenna, your beams, the actual geography in play. The only thing that it can't detect is any kind of interference that's currently there. But for the purposes of just laying everything out on the map exactly where you want it, this is where this is going to benefit you. It also helps to choose the exact equipment that's appropriate for your installation. So in some cases, you think you may need a certain device. It may be too strong for that particular install, and you can adjust which equipment and run it with different pieces of equipment to see what the numbers look like. So it gives you a really good idea of what to expect from the link itself once it's up and running. So again, we have all our custom equipment preloaded into this in a drop-down menu, but there's a custom option that allows for third-party equipment, or if you're using our connectorized equipment, to put in custom antennas and beams, whether it's omnidirectional or directional. So we have 3 different modes when you're working with a link calculator. One is the point-to-point mode. This was the most complicated and complex, the first mode where you could really put a master and a slave or an access point and a station directly on the map in a point-to-point configuration. We then developed something called Pointtomultipoint. This was our first try at the point-to-multipoint, and it had a couple limitations in that it's not as extensive as your point-to-point. You don't get all the options, and then we put into play the Point-to-Multipoint Complete, which is almost identical to the point-to-point. It has the same options, but allows you to place multiple receivers on the map and get an idea of the layout and whether they're going to fit within the coverage area. So when you log into the linkcalc.ligowave.com, the first thing you have to do is create your custom account for you, and this helps you to organize your links and save your links, so all this is available to you. And then you get the home screen where you can choose which mode you're going to use. You can go and use the Bing maps or the other maps, which are a Chinese version. Most of the time I stick with Google Maps. They're up to date, they're constantly updated, so you're getting the most accurate information using the Google Maps. Okay, so here is the home screen of the link calc, where you choose your mode, and you can select from the different map types. So for the first link, the point-to-point coverage, this is what it looks like when you log in. So you get to choose your name of your transmit and the name of your receiver, and in the drop-down list, the radio type. What is good about choosing the equipment from the drop-down list, it's going to auto-populate all the information for the radio, the gain, and the transmit power. The only thing you'll have to enter is the antenna height. And the option to locate these areas on the map is either by a physical address or GPS coordinates. So if you click on the transmit side, type in a physical address or GPS and search, it's going to auto-populate your latitude, longitude for you. And the same thing for the receiver side. Once this information is populated, you want to make sure you put in your antenna heights. Then you calculate the link, and it's going to come up with your results. The results are going to tell you if this link is possible. So you look at your signal level. Again, in this case, it's like -51, so it's perfect. It's right where you want it. But you're also paying attention to the graph. The graph in the green area shows either like the physical ground or buildings. You want to make sure that your line of sight is completely unobstructed, and this is what this graph will help you decide. So you don't want anything blocking your coverage area, and that way you can ensure that your link's going to be as optimized as possible. The link just above there, where you click on your expected bidirectional throughput, this will give you an idea of what to expect based on your channel width. So this will give you your throughput output expectations. And again, all this is just assuming that you have a perfect link. It cannot take into consideration interference, their equipment in the area, but it can tell you physically, if everything's perfect, this is what to expect from the link. So if you're planning like a big project, you want to know ahead of time where to place your equipment, and if where you're placing it's the optimum location for your links. So once you get a look at this, if you see across the top when you do the final results, you have an option to look at the map. And the map is displayed in one of two options, just regular map view, and then you can also select satellite view. So this will allow you to really zoom in real close to the location so you can see exactly where the physical devices are installed, whether that's a pole, a mast, a building, wherever. You can kind of put it in the exact area where you want it. So this is what a point-to-point would look like. Just two locations, the name of the transmit and the receive. In this case, the antenna heights are way too low on one side, so you can see that the area is covered by the physical geography. And if you look at the signal level, it's negative 108. So this signal, this is not going to work. This would not be possible for that link. So this is where you could go back to your parameters and adjust your heights or the equipment you're using to try to redesign what you're working with equipment-wise and height-wise. Another option, and it's built in error-wise, is to see that you have put in too long of a distance to cover. So in this case, instead of putting in a point-to-point, you might have to put in a point-to-multipoint or like a center location and repeat further past there because this distance is way too long. Now the other option when you see this is you're using maybe an integrated antenna, and your option would be better to go with an in-connectorized version with a bigger antenna to go further. So the point-to-multipoint looks very similar to the point-to-point. You can see across the top, though, it has the different signal output levels and colors, and you have your transmit and receive, but what you would normally expect for point-to-multipoint, that you'd have multiple receive areas. But in this case, you only have one receive area, and you put in the same information you put into as a point-to-point, but when it comes up on the results, you get like a circled off area where if your equipment's placed in this area, it should be a possible link. This will work. See, unfortunately, it goes in a 360, and it's not taking into account your directional antenna and your beam widths. So you still have to do some work to try to figure out if where you're placing the equipment is going to work. And that's where the point-to-multipoint C comes in. Again, we can do satellite view, where we have options to do multiple receive sites. And this is beneficial because here it looks just like your point-to-point. You can actually name each location, and you can add them manually through here by GPS coordinates, or you can go directly to the map once you set your transmit site and just click within that coverage area and place the receivers wherever you want them. So in this case, the results comes out instead of just one point-to-point, you have each individual receive area listed and the specific statistics about whether those links will work. So this is beneficial. So if you see one where the coverage area is dipping down into the green, you can adjust physically those heights and specific to that one receive area. You'll also notice that like in one of these it's like neg 33, which is way strong, but again you can adjust the transmit power. But where you see it's some crazy number like a positive number, just means that these distances are way too short to get an accurate count. So in this case, either you can reduce the antenna, the device you're using, a smaller antenna, or you can adjust the transmit power down to get this optimized to work proper. But here again is the map, and you can see the individual physical locations of each device, and you're looking at it in a satellite view. So had we just put that first initial point, we could click anywhere on here and it will just keep adding additional receive areas. And then you can go back to the parameters and adjust the physical device you're using or the height, or you can even grab hold of these and physically move them around on the map. So a lot of times you'll get a GPS coordinate and it's like an address that covers a general area but not the exact point where you're going to place the equipment. So this allows you to go back in and move the equipment around where you physically want them. Again, satellite view, you can really zoom in. In this case, this is like a parking lot. So if you would put some poles in here, you can physically drag these around to the exact location, and you can see the beam coverage area and make sure you're in this beam coverage area. So you can also take the physical access point and adjust the beam where it's physically pointed. When you first put it in, it may be pointing the other direction. So within the adjustment side, you can change the beam like whether it's 180, 0, 360, you can flip that beam around at different directions. So once you get this information entered, then you want to see, maybe your coworker may want to see a copy of what you put in, analyze it, or you may have a question for support. You want us to look at it, see if it looks like it's the right equipment, or the statistics entered, the heights and everything look correct. In that case, we can go in and create a public link, and this can be shared with your coworkers or support staff, so you can come back and look at these and adjust the settings yourself without having to recreate everything manually. So that public link, you just copy it and then send it to whoever you need to see it. Now the other thing you can do is create a PDF report, very similar to the link, but it just copies all the data and all the graphs in a PDF format, and you can do with it, send it around, send it to email, send it to support. Again, it's all the data from this specific link, including the heights and the equipment used. And a lot of times, if you're working on like consistently different installations, you might want to save these records to come back to it later, whether you're going to duplicate something similar, or maybe you just want to come in and play with different equipment or adjust the distance or physically where the equipment's located. You can save the records, and it comes up with a list of everything that you have done to this point. You can go back in and edit the record, delete the record, or create a link from here. So that is basically how you go in and enter stuff, but I wanted to go back in here and show you the actual link calculator homepage. So if we go into the point-to-point mode, we're going to choose by default a 590 and a 5SU23. So I'm just going to copy an address in here and search. So it automatically threw it on the map. We're going to zoom in. I was telling you before, in this physical location, we're wanting to put the stuff on this side. So the beam is facing the wrong way. So we're going to go back in here under the parameters, and we're going to change the beam center to 180. And we're going to give it a little height, assuming it's like 20 feet above the ground. Now we go back to the map, and the beam center is now sitting where we want it to and covering the parking area. So then we can take this and say, okay, so that's not quite covering all the parking area. We're going to drag this over a little bit so we can mount it here. So now we can zoom in and just say we want to put something here. So there's a location, there's a location, and there's a location. So this one we changed, we maybe want to move it over here now. It's better right there. So then we go back to the parameters. We've got all our equipment in here. We've got physical GPS coordinates for everything. We can go through here. We've got 3 transmit sites. And we can go in and say these are not going to be sitting flat on the ground. We want to put a height in here. So at this point, we have everything on the map. We want to actually run the link. Okay, so we can go through each one and just verify that physically looks like there's nothing interfering with it physically. So it looks like in this case, these would work perfectly. So you can go back to parameters if you want and actually give each little site a name if you want to order. Maybe it's a camera. Maybe it's just for a data link. You can rename each one of these individual sites for what it is. So when you get to the results page, you can go back in here and save the record or create that public link so you can send it around. And say you get back in here and you don't like what you're seeing, you can go back in here and say change the equipment type and then run it again. So that could change. Yeah, so in this case my beam center went off. The map is no longer on there. We changed the beam center so everything's outside the beam. So in this case we would like, oops, we need to go back in here, change that back to a 90 because the coverage area is not right. So it does have built-in error codes. So if you put the wrong frequency or your physical locations are outside of it, it'll warn you. that is what the LinkCalc does for our equipment. And then there is actually that custom option that I wanted to show you, that everything shows up blank. So right now everything's populated. So if we do the custom option, then all this information is blank. So you have to put in the actual beam width. So in this case, a 360 would be an omnidirectional. You could put in a 30, a 60, or whatever your physical beam is. And again, a beam center. If you're using directional, you could flip it any direction you want. So that would be how you work for like a custom access point or one of our in-connectorized versions with a custom antenna. Another option up here would be to change to metric. And this is good for our Canadian customers or anybody running things outside the US that use the metric. And all the same rules apply. It just configures everything to a metric version. You can always go back to the map, change it over to regular map view, or go back to satellite. And all this information is saved. Once you get that saved, you can come back in and adjust any of this. And you can create unlimited numbers of saves in here, so you can have your whole portfolio back here under your saved options. Does anybody have any questions about the LinkCalc? How it works? Actually, I love this because you can pick the equipment, but you don't necessarily know if it's going to work for your installation. This is a great help planning out your install.
Hey Leslie, this is Daryl. Back at the graph that shows the various Fresnel Zone lines that you guys have, can you explain the various lines and what or if our throughput performance, how it's going to be affected if we have obstacles in, let's say, the bottom two, but that top yellow line is able to transmit free and clear?
We did look at one where it was shooting through the green. One thing is with the Fresnel Zone, it's essentially the turn of the earth coordinated with the physical geography and like the heights above ground. So if that first Fresnel Zone is shooting through the green, it will significantly affect your signal level, even if you have line of sight. Because of the curve, it's essentially just sending the signal down into the ground. Even if you have line of sight, it's affecting your overall quality of the signal. So we can go back so you can see. So in this case, it's shooting through the ground. And if you see the signal level, it's negative 108. So this would never work.
So what was the slide that was right before that? That one right there. So if that height were down just a little bit, our purple line would be obstructed, and maybe it's coming in contact with the ground right there at the beginning, on kind of an eighth of the way in on the left side.
Right.
Can you kind of explain how that is going to or not going to impact the signal transmission?
It will affect the signal, but keep in mind that signal level is directly correlated with your throughput. So if your signal level goes up to like neg 80 or upper neg 70s, then your throughput goes way down. And if it gets in the neg 80s, you're not going to have a stable signal. So if you're looking at something, say for an instance, you have a maximum amount of height that you can use on your mast. You are limited to that. You cannot make it any higher. If that purple line does touch or slightly go under that green area and your signal level is still high enough or strong enough to get a good link, then it's not an issue at all, as long as you're willing to accept the throughput will be a little less than optimum. So you're looking at a combination of that physical graph with your signal level.
And then I think also if you move your cursor along that pathway,
like here,
do you not see the noise level?
Yeah, if you click on the little eye there, you get exactly what it would be channel width wise with this specific link. It might be more for the point-to-point that does that. I think the point-to-multipoint is a little more simple in terms of what it shows on that graph. So again, probably the users who are not as technical just look at this and they go, okay, it's above the green, so we're good, you know? So if it's not like something where you're really trying to like really pinch it through because it's really close, then most people go, yeah, this is good. I know this is a good link. And the option is always to send it to us and we can give suggestions on heights or different antennas or different devices if it doesn't look quite right. And it's always good to be able to come back to these parameters and adjust because we play with this a lot. Like in this case, it's 190 height on the first mast. and that's to get over the geography, and that's pretty tall mast. So you may not be able to do that in real life. So you have to know when you're going into it what you're capable of, what your materials are, and if you can build a mast that high, or what's the max you can build a mast in that area. And I really like that. One of my favorite things is that you can really zoom in, and you can physically move this exactly where you want it. One thing I didn't really go over, and it's a little more complex, and you probably need to know a little bit more about the physical geography where you're going, but if you do happen to install on a location that has a heavy rain, like a very difficult install, you can change the temperament down here to match whatever physical location that you're putting it in. So if you get a lot of rain, it'll take into consideration like the fades, and if that link will work when it starts raining really hard. But for the most part, I usually just leave it continental temperament, because mostly everywhere here is going to be pretty stable in terms of like no extreme. I mean, in cold weather is already calculated into the physical hardware design, so it's not like unless you have a lot of ice that's forming on your dishes or your antennas, it's going to work. So that's our link calculator. It does take a minute to get used to it, but once you do, it's just like second nature, and it's really super beneficial and helpful.